In this video, we'll be using the tangent ratio to help us find a missing side length. So example 1. A ladder leaning against a house touches the ground at an angle of 75 degrees. If the ladder reaches a height of 7 meters, how far is the base of the ladder to the house, to the nearest tenth of a meter? So first I notice that 7 is across from the angle, which means that this is the opposite side, and x is next to the angle, which means this is the adjacent side. So now setting up my tangent ratio, I'll say tan of theta equals opposite over adjacent. So here we're not looking for the angle, we're given it, so I'll fill that in for theta. Tan of 75 degrees is equal to the opposite side, which is 7, over adjacent, which is x. Now when we're looking for a side length, in order to solve for x, we need to cross multiply. So I can put the tan of 75 degrees over 1 to make it into a fraction, and easier to cross multiply if you like. So we'll start by multiplying x by tan 75. And then we set that equal to 7 times 1, which is 7. Now we're trying to isolate x here, so what we can do to both sides is divide by tan of 75. So then the tan of 75 cancel, and you've got x on the left, and on the right we have 7 over tan 75. Now we're not looking for an angle here, so we don't need to use our tan -1 button. We can just use the tan button. So enter 7 divided by tan 75. And also check to make sure that your calculator is in degrees. When you do that, you should get an answer of 1.9. So now we can say that the ladder is 1.9 meters from the house. Example 2. Doris is walking along a level road and sees a mountain in the distance. Using a clinometer, which is a device used to measure angles, she measures the angle to the top of the mountain to be 13.5 degrees, and she knows that she is 15 kilometers away from the base of the mountain. What is the height of the mountain to the nearest tenth of a kilometer? So since we don't have a diagram here, we'll have to draw one ourselves. So I'm going to let this dot here represent Doris, who is looking up at the mountain, top of the mountain, which we'll say is here. Since we're looking for the height of the mountain, that is straight down. And we know that she is 15 kilometers from the base of the mountain. So here's my little right triangle we're going to use. So let's fill in the values. Doris is 15 kilometers away from the mountain. She's looking up at the mountain at an angle of 13.5 degrees, and we're looking for the height, which I'll represent as x. So now using our tangent ratio, I'll fill in my angle theta to be 13.5 degrees, fill in my opposite to be x, and my adjacent to be 15. So once again, we will cross multiply. You can write this over 1 to make it into a fraction. Now this time, because x is in the numerator of the fraction, we're multiplying x by 1 here. And x times 1 is just x. And we're multiplying 15 by tan of 13.5 degrees. So when x is in the numerator, that is great because we don't need to isolate x. X is already isolated. We can just go ahead and multiply 15 by tan of 13.5. And doing that should give you a value of 3.6. So now we can say that the height of the mountain is 3.6 kilometers. Now example 3. Marilyn is planning to install a ramp by her back door. The vertical distance of her doorway to the ground is 0.6 meters, and she wants the ramp to be at a recommended angle of elevation of 4 degrees. How far from the house will the end of the ramp land? To the nearest tenth of a meter. So again, let's draw a diagram. So if we say that this is the top of the ramp and the vertical distance straight down to the ground is 0.6 meters. And then this is the actual ramp, which has an angle of elevation of 4 degrees. So remember that angle of elevation is the angle between the horizontal line and the line above the horizontal line. So 4 degrees will go right here in our diagram. Now, we are looking for the distance from the end of the ramp, which lands here on the ground, to the house. So setting up our tangent ratio again, I'll say tan of 4 degrees is equal to 0.6 over x. So now cross multiplying, putting this over 1, I have to multiply x by tan of 4. And I multiply 0.6 by 1. So here we need to isolate x, so that means we need to divide both sides by tan of 4 degrees. So canceling those, we get x equals, and we need to use our calculator to divide 0.6 by tan of 4. And I got 8.6 on my calculator. So see if you get that as well. And if you didn't, then it might be that your calculator wasn't in degrees. So now I'll answer the question by saying that the end of the ramp will be 8.6 meters from the house.